Okay, this is PreCalc 3.3. First problem wants us to change things in the log form to solve these expressions. Now we can do this on a calculator, but we can try to do it by hand as well because we know how to change things into exponential form from log form. So let's let this equal something like x, and let's change it into exponential form. So we do base to the exponent equals the argument. So keep in mind that a log is an exponent. So from there you can see that, okay, here's the base, obviously, and you can raise it to the exponent, which is right here. And then you'll get what the argument is. So another way to remember this is to make a circle like that. I don't know, there's other ways to remember it, but the best way I like is to remember that a log is an exponent, because then it tells you that this is always the base right there, and this is always the exponent in a log expression, because a log is an exponent. It helps you remember that, that's what a log is in the first place, which people, leave this class not even knowing what a logarithm is. It's simple. It's just the answer to an exponent problem. It's this right here. It's what would we raise 2 to get 2 to the 13. That's what the log is. The log is this answer right there, which in this case is 13, as you can compare 1 to 1 here. But that's what you need to do. You need to change things into log form and exponential form. So let's do this again. This is 13. So once again, call log base 3 of 81 equal to x, and do base to the exponent equals 81. Now, I'm going to check for work on these because you can do these by hand. 81 is 3 to the 4th. So, rewrite 81. These are going to be perfect cubes here, and you'll see that x equals 4. Okay, so the answer is x equals 4. Or this equals 4, right? So this expression equals 4. And you can do that on a calculator double check, but I want to see this kind of work because we should be able to do these by hand. And I want you to be able to do these by hand. Okay, so log base 4 of 1024 then is next. Call it equal to x, so 4 to the x equals 1024. Now, raise 4 to some power in your calculator to find out what this is. So, try 4 to the 3rd, 4 to the 4th, 4 to the 5th, but it's probably some power base 4 because we want to compare 1 to 1. And if you try 4 to the 5th, that's it. So that means that this whole expression equals 5, or x equals 5. And you can try that in your calculator again to make sure, but this does equal 5. All right, so then the last part, log base 9 of 9 to the 3rd, call it equal to x. Change it into exponential form by doing base to the exponent equals the argument, in which case x equals 3, and we're done. Okay, the next problem is a really good problem. It wants to know the domain of this function. I'm going to call it y equals log base. And instead of using base a, I'm going to use base 2, just to make this a little easier because I know we're more comfortable with numbers. Just trying to make it look comfortable for you. So here is this expression, this log function. Now we're trying to find the domain of this. Now you might want to be tempted to graph this first. So take a look at the graph and see what it looks like. Now actually this is the first time I've seen a graph for failure on Desmos, but it's clearly a graph of failure. This thing keeps going down. It does have some asymptotes here, but it does go down to negative infinity in both these branches, which it doesn't show. In fact, as you scroll in, these things keep changing, which is weird. Just some kind of graph of failure based on the programming of this software. But we need to find this domain then algebraically. We need to somehow reason through what the domain would be. So one thing that I think helps is to change it into exponential form and see that base to the exponent equals the argument. So this is basically what the same function is now, rearranged, same function. So what we're asking is when, what can we stick in for x basically here? Well, we have an issue when we end up getting a negative number here, because you can see that there's nothing I can raise 2 to get a negative number over here. 2 to the negative power is just like, say it's negative 7, it's really 2 over 7 then. Or I'm sorry, 1 over 2 to the 7th, if this was a negative 7. So you really have to just make sure that this is positive. Also, if this were 0, that doesn't work either, because there's no way to raise this to some power to get 0. 2 to the 0th is just 1, which is not 0. So basically, when you rearrange this and start reasoning mathematically, you can see that this has to be greater than 0. So I know that x minus 7, x plus 7 has to be greater than 0. And that's something good to know because we're going to run into that in this class. You're not going to be able to take a log of a negative number. And the reason why is right here. is because you can't raise some base to a power to get a negative number. So we're going to make a sign chart again, where you put on there -7 and you put on there 7, and we want to pick a number that's less than -7, like -8. That gives us a negative there and a negative there. Those turn into positive when you multiply them. Pick a number between -7 and 7, like 0. 0 gives you a negative times a positive, which is a negative. And number greater than 7, like 8, gives you a positive and a positive, so that's positive. So these were zeros here and here. So we can't have those. We can have all the numbers in between. Or, I'm sorry, we can't have all the numbers in between. Our domain is going to be all these numbers and all these numbers, where this is positive. So on web work then, you can say the domain is from -infinity to 7, or -7, and then from 7 to positive infinity, which is exactly what our domain is here. Okay, the next problem gives us some functions, wants to know if these are equivalent. So the first one, log base a of 3b, is it equal to 3b times log of a? That's the natural log, by the way. Yes, that's true. You can bring the exponent down. That's one of the properties. And by the way, I did put these properties in your formula sheet. So if you scroll down, I just added these to remind you that I did log form, exponential form, change of base theorem, and these 3 log properties, the ones that we're going to be talking about. I'm missing one actually. Oh, I'm sorry, it's right here. So this says you can take the exponent x and bring it down in front, right there. So here's our 3 log properties that we're looking at right now. So you can bring this exponent down; those are equivalent. So yes. This next one is no. There's no property that says we can take this exponent right here and bring it down to multiply, but not to add right there. So you could try this with numbers too if you want. Just pick a number for x and a number, and give this a try. You'll see that this does not work. Okay. The next one is using a combination of log properties that is equivalent. You can see it if you bring the exponent down. So if you do log and bring the 1/3 power down, because that's what a cube root is, you have x times y. And there's another log property that says we can turn that into natural log of x plus natural log of y. So the product of a log of a product is the sum of 2 different logs, and that's on the formula sheet right here, right here. Right here. A log of a product is equal to the sum of the 2 logs. So you can do that, which is the equivalent expression then. And the last one is not true. You can try this with numbers again or graph them both in decimals, but these are not equivalent expressions. You can take this base and put it down front and multiply, but you can't square the whole log. It's a very different thing. So no for that one. Okay, the next problem then gives us h of x equals natural log of this. We need to figure out what the domain is. We could graph this, but like I said, decimals isn't very clear on the domain. So let's look at it algebraically. I'm going to change this to y. We can change this into exponential form by doing base to the exponent equals the argument. And then we can look at, okay, well, there's no number I can raise e to get a negative number or 0 here. So basically, x minus 2 has to be greater than 0 because you can't raise this and get a negative number or 0 for that matter. So I can add 2 to both sides and get x is greater than -2, or x is greater than 2 rather, as my domain. Now they want us to write that as an inequality, so let's do 2, not including 2, all the way to positive infinity, and maybe write I enough for there instead. Okay, the next problem then gives us the pH formula for the relationship between hydrogen ion concentration and pH, which is logarithmic. It tells us what the pH is, so we can write this equation, and we can then solve for the hydrogen ion concentration. To do that, I'm going to multiply both sides by a -1. I'm going to change this into exponential form, so I'll do 10 to the -1 equals the hydrogen ion concentration. That's base to the exponent equals the argument. Change this into log form. If you're not sure how to do that, maybe go back to the first problem, where log is an exponent. So the hydrogen concentration is just 1 over 10, and that's your answer. You can enter that as a decimal if you want, moles per liter.